Yo, what is up, everybody? Hope you can hear me. Good morning, good evening, good afternoon, wherever you're at. I got my coffee. Shout out to Tim Hortons. Not getting paid, not getting sponsored, not getting free coffee unless you roll up the rim to win. Cheers to everybody out there watching. Thanks for joining us. I want to bring on an amazing guest, a really awesome friend of mine, Mr. Austin Gill. What is up, my man?
Hey, what's going on? I just got back. I just went to grab some water. So,
you know what? Go do that, and I will chat up the audience for a minute.
No, we're sorted. I just wasn't sure. I sat down and I was on screen. Let's do it.
Perfect. Let's see. Are these captions? The captions are working perfect. So I installed a caption. It's called Stream Closed Caption. Todd Libby told me about it since we were both in the accessibility space. It has to be a brand new thing because this didn't exist before, and like there was no plugin for Twitch, there was no plugin for StreamYard. So I'm really glad this is working, and I got Twitch on another screen, and it's working. So that's really, really cool. First time chat. What's up, Jordan? How you doing, brother? Let's see here. Yeah, we are good to go. Thanks for joining us. So yeah, the closed captioning is working. I'm seeing it work on Twitch. That's awesome. How are you, man? How are things on your end?
Oh, it's been good, man. The conference seasons this year has been weird for me. I accidentally double booked a couple, or not double booked, but like didn't manage my schedule very well. So then I had the problem of being accepted to two that had a conflict and having to send a I'm sorry letter. And then, yeah, it was kind of rough, which is a shame, because obviously a lot of people put time into selecting speakers and filtering things. And it was just like, shoot. Okay. Lesson learned, manage my calendar better.
Yeah. It happens. I mean, there's so many events that like if you really don't have like a travel agent or somebody that's like watching your calendar, I've done it. I've booked events where like 2 or 3 in 1 week and had to figure out flights to get one to the other. It's super stressful. It happens. It is what it is.
Yeah. Yeah, and also like it's tough because some of them the CFP opens like 6 months out, and you're like, I have no idea what I'm going to be doing in 6 months. Right. And then all of a sudden, you got to start figuring out your summer plans, or people want to come visit, or this and that, or Anyway, all that first world problems. Am I right?
There you go. Hey, the problems of a developer advocate, I guess, right?
Yeah.
Awesome. Well, I'm glad you're doing good. Glad you're doing good. So for anybody that doesn't know who you are, give us a little rundown. Give us a little spiel on Austin Gill.
Oh, yeah. I am a developer advocate at Akamai. Been doing that for a little over a year now, which has been great. And before that, I have about 10 years of experience engineering, building and breaking and fixing websites and stuff. I do a lot in the JavaScript world, definitely lean more on the front end stuff, but I've done a lot of like full stack, databasey, building APIs stuff as well. Love some CSS and accessibility stuff. And yeah, it's just, I don't know. I never like to pigeonhole myself into like one thing. If it's web development, I'm interested.
Yeah, cool. If anybody wants to follow you on Twitter, how are they going to do that?
Oh yeah, on Twitter. Yeah, I'm really bad at promoting my stuff. Yeah, I'm on Twitter at Hey Austin Gill. I'm also on Twitch and YouTube at that same handle. I do open source work. I spend a lot of time in the Vue ecosystem, and I have like a Vuetensils library that's kind of an interesting concept. It's I call it like naked components, where you basically have the component library is responsible for the markup and the functionality, with the intention of like making it easier to build accessible UIs. But then developers that are consuming the library are responsible for bringing the styles. So you don't have to fight with a bunch of styles that are heavily specific or don't match your brand guides or whatever. Not great if you want something that has its own styles, but pretty good if you want to build accessible and bespoke applications, I think.
That's awesome.
Yeah.
You're doing a lot of dope things over there.
Yeah.
It's good to hear.
Yeah, but this year, since joining Akamai, a lot of my focus has been on edge compute. So I think that's what we're going to talk about today, specifically how it integrates with A/B testing and feature flags. Moonlight as a dubstep DJ, that's right. Only for shows that Todd Libby is going to be, slaying some rhymes on. But yeah, I work at Akamai. It's pretty great. It was essentially a company that was originally founded, I think kind of like invented the idea of a content delivery network or CDN, where essentially you have a service that is a network of computers distributed around the world. I think Akamai currently has over 300,000 servers globally distributed. And the idea is the problem that they're solving is when a website loads and you have assets that you have to load, such as fonts or CSS files or JavaScript files, all of these static things, those don't change very frequently. And when a user requests a page, does the DNS lookup, the TLS handshake, and all that, makes the HTTP request, the browser or the server responds with HTML, the browser parses that HTML, finds those static assets, and then has to pause loading of the page to go and get those assets. And depending on where those assets are stored, that could be like a very long round trip, very long being like a relative term, maybe 300 milliseconds or whatever. But the idea being that if you can bring those assets closer to where the user is that's loading the page, then that network request doesn't have to take as long. So you can effectively speed up a page by putting assets closer. So how do you do that? Is you have a network of, again, like 300,000 servers around the world. You take those assets, the static assets, and you basically can put a copy of them in each of those locations, such that when a user from Tokyo requests the page and tries to load the CSS, they're getting it. They're only going to the CDN location in Tokyo. And then if someone's in Toronto, they get the one from Toronto. If someone's in Toledo, they get the one from Toledo, right? So that's what Akamai, I think, invented the concept. And there's a lot of other CDN providers now, but they're like the most oldest and most established. And I think that they mostly work with enterprise customers. So I have to be careful that only certain customers want us to share who we're working with publicly. A lot of people like not sharing that public information. So let's just say that some of the largest brands in the world, probably the first brand that you can think of, is probably using Akamai. Some of the largest, so all this to say, it's over a 20-year-old company, and CDNs have come a long way. And once you have network of traffic going through a CDN as the sort of entry point into this network of protected and connected servers, you have access to a lot of other nice features, such as the network of computers that the CDN controls can start watching and analyzing the traffic that's being distributed around the world and seeing patterns in the traffic, such as detecting anomalies that are security concerns or likely security concerns. So CDN's adapted to start offering things like web application firewalls, where if you have traffic from certain countries trying to access your website, it can be stopped like at the CDN level. So you have security benefits. And then more recently, they've introduced this concept of edge compute. So one of the problems with that initial HTML request is, sure, if you have a static HTML file, you can serve that. You can deploy that at a CDN and have it be super fast response. But most applications or many applications want the HTML to be dynamic, which you can do either with JavaScript on the client side, but that has its own downsides. Or you can do that on the server side with the scripting language like PHP or JavaScript or Python or Go or whatever. You still have to deal with that round trip latency though. So if I'm in Portland, Oregon, or my website, let's say I deploy my website, I don't know why, but in Tokyo again, I'd have to go all the way to Tokyo. I'd have to make a request all the way to the server in Tokyo. That request would receive the server would receive the request, do whatever sort of computational logic it wants to generate the HTML, and then still send that back. Now, there's no getting around the computational work outside of optimizing your code or improving the server resources, but the time spent actually in transit going to get that request and make that round trip request is just kind of like dead time, right? It's useless. It doesn't help me. It's not actually producing anything for anything of value for me. So CDNs have kind of shifted to taking those 300,000 servers around the world and saying, instead of serving just static assets, what if we can provide a way to modify the HTML or generate HTML as close to the user as possible? And that introduces the concept of edge compute. So once again, I don't want to misquote myself here, but I've heard that Akamai was, again, one of the first companies to pioneer the idea. And it's an old idea. When we talk about computer science, so many of the concepts that we're actually playing with today, like quantum computing or AI, they've been around, the concepts, for decades. It's amazing when you look at how much advancement was made in computer science in like the 70s. And we've just been like rehashing it or actually finally having the computational ability to bring them to life. So yeah, I think Akamai was one of the first companies to pioneer it. But for computational reasons or technological reasons, it wasn't quite feasible up until recently. And we've had it since 2017, I think. I could be wrong there. But yeah, so it's interesting. And what edge compute brings to us is a really interesting paradigm shift of being able to deploy dynamic applications as close to the user as possible without having the downside of server-side rendering, which includes that sort of long trip latency, and it also doesn't have the downsides of static rendering or static asset deployment, where you can't do dynamic data on the back end. Does that make sense?
Yeah, no, it makes a lot of sense. I haven't kept up with like the CDN world in so long. Like when I first started using CDNs, and who knows when that was, as a content delivery network or code delivery network, or however you want to, shake that out. It was just a place to grab code in the cloud or someone's server, right? And just serve it to your, down to your application, wherever that code may be. Like there might be like 1,000 different cloud repositories that the CDN exists, and you just grab whichever one's closest to you. So that's still been my familiarity with CDNs, but it seems like that, like the early days of a content delivery network or CDN has evolved like tremendously to like a different level of delivery.
Yeah, it's sort of funny because at the end of the day, well, you touch on one thing that's funny. It's like, yeah, there is no cloud. It's always someone else's computer, And now we're talking about something that is even more a nebulous of a concept, because it's not just someone else's one computer, it's someone else's network of computers. And I can't tell you, if I deploy a cloud computing instance in some region, I can roughly tell you at least like which data center the computer might live in. If I deploy something to a CDN, I can't tell you where it exists. I mean, a CDN may provide where their points of presence are, but for any one request, I can't tell you which one necessarily, which server necessarily is like handling that request. probably the one closest to the user or the point of origin. But yeah, it makes for some really interesting networking things. And sort of the magic here is like I can just configure it and set it up, and then let someone else think about that, right? It really abstracts some of the problems to someone else. So, for example, the problem being, let's like take a step back in time and say, if I have an application and just like very bare metal want to deploy my application, okay, I need a computer, I need a server. Now, outside of putting a server rack in my garage that's going to, stay up or be down, or I have to maintain, we'll stay modern enough that we're living in the cloud. So I can deploy an application in the cloud. I can get a virtual machine or whatever and manage it and put my application there. I still have to decide where I'm going to put that server, right? And the problem there is, the decision making there has to be based on where my users are going to be. So you put your server as close to the user as possible, and that way you reduce the latency. And that's great for small applications or very localized applications. But if you are serving customers from all over the world, that becomes a global problem. And then all of a sudden, there's not one place that necessarily stands out, right? So yeah, it's an interesting problem to solve. It's really nice. It's really nice to have services that have kind of solved this for us and offer these solutions. And I also think it's worth mentioning just kind of how CDNs sort of work to begin with. We'll get into the edge compute stuff in a moment, but I think this is particularly interesting of how easy it is to make this process work and like coordinate everything. You basically like sign up for an account, set up your service or whatever. You have to do some stuff at the DNS level because basically traffic needs to route through the CDN in order before it goes to your origin server. And then what happens is, let's say outside of the dynamic HTML generation, right? Let's say we're just serving an image. You can say, okay, after I configure my server, I set up the DNS, I point it to my CDN provider. In this case, we'll say Akamai. It doesn't have to be though. I change my DNS. I change the traffic to go to Akamai, and then I can either do this at like a subdomain level and serve all of my images from, let's say, images.myproject.com, or I can configure it so that I can do it at a path level and say any traffic that goes to myproject.com/images, pipe it through the CDN. And then you can say, okay, so you have your route, and then you have your image file, and let's say we want to get, christamars.lookinggood.jpg or whatever. We want to serve up your profile picture, and we have that URL. And when the CDN sees that URL, it says, okay, it's time to serve this image. And if you're in Detroit and you're the first user from Detroit to come to my website and get that beautiful picture of yourself, the CDN is going to say, I don't have a copy of that. So how do you get that copy of the image into the CDN? And this is sort of the smart thing that it does, is it looks and sees if it has a cached version. And if not, it's going to say, okay, let's go ahead and go to the origin where I know that image exists. So now it's at like, Austin Gill / christamars looking good.jpg. And it's going to grab that. It's going to serve that to the initial user. And then for every other user after that, it's going to have it at the Detroit location. And it's just going to serve from there. So the first request is just about as long as it would take to grab the original, but every next request is faster. And this is, this raises the challenge of, well, what if I want to change that image? You can get into like caching strategies and how long you have something stay live, and I think you can do some stale while revalidate stuff. I think a lot of the CDN stuff. Don't quote me on this because I haven't done too much on our CDN level, but I think you can either rely on HTTP headers, which is really nice because then you're using browser or HTTP protocol supported standards, which is great. Or you can also use like Akamai specific APIs to say, hey, go and bust the cache. Or you can even do like programmatic cache busting, where you can say, okay, I know that this image is old and I want to update it. Let's say I hit save on like my CMS, I can trigger something that then goes to the cache and says, hey, go ahead and clear this out, or maybe like specifically clear this image or something like that. So you can do that. But this gets particularly interesting as web development has advanced, because that can be a tricky dance to play. Like caching is hard and clearing, like busting caches is hard. But with modern development, we have these build tools that are no longer storing static assets with the same name. You get like a hash value based on the contents of that file often. So when I create a new CSS file or a new JavaScript file, or I build a new application, generally there's some sort of build tooling that will take those assets and like push them all together and optimize them and make them ready for production. And then instead of having like main.css, which is easy to cache and hard to bust, we get something that's like, xyz123.css. And then the next version is going to have something completely different. So now we don't even have to really worry about the challenges of busting caches, because the static assets are no longer the same.
That's cool.
Yeah.
I like that, how that kind of works. So with the way that works, and this question is kind of looming on me right now. A traditional CDN, like you can have multiple versions. Let's use jQuery, for instance, right? Good old jQuery. You want a jQuery, use a CDN. But there was multiple versions of like that JavaScript file. So with the CDN living, I guess living close, if I'm getting this right, living closer to where it's being pulled from, instead of like hitting something, if you're in Michigan, hitting all the way in California, you're pulling it in from Toledo, right? Or Grand Rapids, Michigan. Are you still today, if you're using a CDN like that, and even with Akamai, are you still pulling in minified, like let's say JavaScript, right? Minified JavaScript, or can you pull in a full JavaScript file and not minify, and not use the minified version because it lives closer to where that what's the word I'm looking for? That
region, origin,
yeah, region, gate, whatever. Like, do you still have to use a minified version?
Yeah, that's a really good question, and there's actually a lot of nuance just in that. So because we're talking jQuery, it used to be recommended that I have like I cut my teeth on building WordPress websites, so jQuery was a big thing, and having different versions of jQuery on the same page was also a big thing, because you have a plugin that wants one version and then you have another plugin that wants a different version or whatever. So that aside, I mean, ideally you serve one version of a library, right? Like, I don't think that there's outside of compatibility issues, there's not much benefit to serving multiple versions of the same tool. So yeah, if you can reduce the number of different versions, that's like a good that's probably the low-hanging fruit optimization I would recommend making, assuming that there's no compatibility issues, because that's going to reduce, one, the number of HTTP requests the browser has to make, and two, the actual amount of data that the browser has to download before it can parse it, right? To answer the question about minifying, I think that minifying, having your code sort of written so humans can read it, only benefits humans. If you have it written in a way that everything is minified and you like every variable is changed from Salt and Burnham to just S, that's going to produce smaller file sizes without a cost to like capabilities or the actual logic of the application, because ultimately a variable to a browser is the same, whether you call it Salt and Burnham or you call it just S. So the functionality doesn't change. Also, white space doesn't mean anything to a computer, right? White space is for humans. So minifying code has the benefit of making the file size smaller. And then when you have a smaller file size, that can transfer quicker over the network. That can also save you on storage costs if you're on the hook for paying for storage. If we're talking about JavaScript files, it's probably not going to be very it's probably going to be like not a relevant storage cost, but it's worth mentioning. If you're, yeah, it's, it's like a benefit, right? So if you have a pipeline that doesn't cost you a lot to set up to actually minify everything, you will see a performance benefit from minifying things. Where things get kind of interesting is historically there was a benefit to concatenating all of your different JavaScript things together, right? So you have jQuery maybe, but maybe you also have all these jQuery plugins, or you have your actual application JavaScript code, right? And this is where things have sort of, I'm going to say that the jury's kind of out on this, because since HTTP2, browsers can support multiplexing, which means instead of being limited to a certain number of connections that they can make at one time to download different resources, the old advice was put all of the JavaScript into a single file so that the browser only has to make one HTTP connection to get everything it needs. And now that may not be the case, because we have multiplexing that can say, okay, instead of one file that contains jQuery, your application code, maybe like day.js or whatever, let's separate those into their three things. We have jQuery as its own connection. We have your application code as its own connection. We have day.js as its own connection, right? And we can download those simultaneously, which can speed up the process because they're smaller files. So those downloads will happen quicker because they happen simultaneously rather than waiting for one large file to download. The problem there, is we just don't have enough data from what I've seen to suggest that that's actually the case. There's also, well, yeah, I'm going to say the jury is out on the file concatenation stuff. I still kind of do it. I think you're probably better off with a strategy of like lazy loading things that you don't need. And lazy loading is this concept of you load everything the browser needs for the initial load on the first page. And then if you need to do like some sort of navigation or something based on how far down the user has scrolled, or based on user interaction, then you only download the additional resources you need for those interactions as they become necessary. That way you reduce the amount of data that's loaded on the first request. That's probably still a strategy that has a lot of upfront costs in your actual technical setup, like your build tooling and how you automate it and the logic around it. Some would say, it's probably not worth the effort for a lot of cases, or there's bigger gains from smaller effort that you can make, right? So that's something I would like. Lazy loading strategy, if you don't already have it or you don't have something that's easy to implement, then I would probably put that off until later in your performance optimization pipeline. But something also that changed when we were discussing the jQuery CDN story. One of the recommended ways of loading something like jQuery in the past was to use a CDN like jQuery's specific CDN or Google CDN or CDN.js or Cloudflare CDN or whatever, all of these different CDN providers for static assets for libraries like this. And the idea behind this was, well, if a user goes to website A and website A uses jQuery 1.4 or 4 point whatever, right? And then user goes to website B and user B or website B makes a request to that same asset or that same CDN, the same version of jQuery from the same CDN, and the URL matches, the browser will have a cached version of that jQuery file ready to load. And this is no longer the case because browsers no longer store cached assets across different domains. So every domain, website A, website B, are going to have their own set of caches. So that's unfortunate. I mean, it's good for security reasons, and I think like fingerprinting was the logic there, but it does mean that we can't use shared CDNs for shared resources. And even so, using a CDN that you don't control is a security concern. Like, you have to trust that CDN. You have to trust that what the file that they say that they're sending you is the file that they say that they're sending you, you know? So that's in itself weighing the costs and benefits of using a third-party provider that may be easy to use versus how important is it that your assets are stored. Again, yeah, sorry, I keep it's just like it's such a deep rabbit hole, right? Because now we get into like more performance considerations when we're talking about loading a CDN from a different provider. Let's say you do want to use the jQuery CDN. Also, when the browser comes across that third-party asset, it's being loaded from a different domain. And when you load something from a different domain, not only do you have those security considerations, but you have performance considerations, because now the way that the browser works, when you load a URL, browser has to go and make a DNS request, DNS lookup. It has to perform a TLS handshake to the server. It has to perform these days an SSL handshake to the server. And then it has to make the HTTP request. When you load something from a different domain, the browser has to go through all of those steps again. So DNS lookup, TLS handshake, SSL handshake, HTTP request. So if you load from the same domain if you load content from the same domain that the browser has already done that, it doesn't have to go through those steps again. But if you're using a third-party domain, now you have a performance consideration about making those requests to and like loading a service and having to do all the handshake stuff again. Whereas if you were to alternatively take the jQuery version that you want to load and load it from your own server or your own domain, your own host, the browser already has done those steps, so it can just go and grab those. Especially if you're using a CDN that is configured to use your domain, then you don't have to do those TLS handshakes again. If you use a subdomain, the browser treats that as a different URL, so you would still take that performance hit. But then there's also the nuance of, do I put it on my main domain, or do I put it on a subdomain or a third-party domain? And then the question is, the suggestion here is, it's faster to put it on your own domain, right? Because you're not doing the SSL and TLS and DNS stuff. But also, when you put things on your own domain, all of those requests are going to include the cookies that are sent for every request that the browser is going to include by default. And so now cookies can affect performance as well. So you can see that it's really hard to answer these questions, and it's very much a case-by-case scenario, and it takes an immense level of knowledge to be able to speak to it about it. And I'm not even talking about I'm not talking about myself. I'm basically regurgitating parts of conversations that I've had with people that are much smarter than me, and trying to present it in a coherent way. So that's to say that I feel blessed and fortunate to work at this company and be able to talk about this stuff, because it's interesting, it's fascinating, it's stuff that I'm really glad that I don't have to think about on a daily basis.
Yeah. Wow. Like, you're just blowing my mind over here with CDN, like all the CDN performance, lazy loading, somebody else's cloud compute machine thingamabob. You're just blowing my mind over. It's a rabbit hole. Like, it is legit a rabbit hole. I did not have a single clue that the CDN world was like as robust as it is. Like, that blows my mind. That's interesting to me, because I would like to do more research on stuff like that. I always kind of like going down into rabbit holes and having a bunch of information that some people just don't care about. Like, I could go to my partner and be like, "Hey, did you know this is what happens when you're doing this?" And then she'd be like, "I don't care, Chris." I'm like, well,
it's good to have those people in your life.
$1 million question.
It is good to have those people in your life.
Yeah.
that are like, let's go for a walk sometime. Let's talk about something outside of tech.
Right. Yeah. Oh, I do that all the
Um,
time. I do that all the time with the immense knowledge I have on UFOs and cryptozoology and
yeah.
paranormal, and
Oh yeah, that's good stuff. That's right.
yeah, that's my world, man. So
Um, yeah. So I want to kind of take a step back. Like we went really deep there
we did.
on into the rabbit hole, into the nuance and stuff. And I think it's cool and interesting and fascinating because again, like I love how this stuff works. I love the technology. I love learning about it. But let's taking a step back and realizing that what we're talking about, all of these performance things are the biggest performance gain that we've discussed so far is probably around latency, right? Putting resources closer to users to reduce the amount of time that the request has to take in transit. That's probably, out of the things that we discuss, the longest, the largest potential to save the most. And we're talking, the longest requests can be halfway around the world until we figure out how to drill a hole and drop and lay pipe through the middle of the earth, or figure out like wormhole technology. The longest request is going to be from one side of the planet to the other, and that is bound by the speed of light, right? So the fastest that can be is the speed of light. Now, how long does it take for a request to go, like worst case scenario? What's the most amount of time that we can save users? 300 milliseconds. Like we're talking about work and knowledge and experience and things and efforts that people are putting in on this 300,000 servers around the world. Like the scale of effort and energy and time that has gone into this to solve a problem that's 300 milliseconds. To me, like I take a step back and I'm like, oh my gosh, this is so cool and interesting, but why spend so much on so little? Because 300 milliseconds, we're talking, I mean, you take a breath or something, like you I don't know, sneeze. That's it's like it almost seems like such an insignificant amount of time, but it's not, right? So I do want to get to the edge compute stuff, but like all of this stuff, all of the concern around CDNs and how you do your networking, and whether you use your domain or not, and whether you use third parties and all this, it's all about performance, right? And there's other things to worry about on the web, but in this realm, the main focus is performance. And the reason why so much energy and time and effort and thought goes into it is because it does matter to people. At a certain scale, it doesn't matter. At a certain scale, like 300 milliseconds, your customer is going to wait around. For certain applications, 300 milliseconds, your customer is not going to care because it's their bank or whatever, right? Like I'll wait longer because it's my bank. I want to see where my money's at. But if you're in a position that the stakes are high and there's a lot of competition, there's a lot, any competitive edge means $1 million difference. Yeah, it's worth it, right? So I think Akamai put a study out on consumer. It's one of those, like I have it in the talks that I give about this. It's like the compulsory slide full of stats that just like basically confirms that yes, performance matters because people have more trust in websites that are performant. They convert more, they stick around longer, they come back, and all this stuff, right? So it improves conversion rates, and ultimately conversions lead to well, most often conversions are related to money, but it could be whatever your goal is, right? Getting information out, getting people signed up for your newsletter, getting people to know about emergency events, like when we were in the middle of the pandemic, getting vaccination status updates out to people, like important things, right? And so yes, performance matters. And when we're talking about, again, sort of the largest companies in the world, it matters a lot. Like there was a study I saw that Walmart did some performance research and found that for every 1 second that they shaved off of their loading time, it was like I don't know, like a 1% increase in sales. And you think, well, 1% is not that much until you realize Walmart made like $500 billion in 2021. I don't remember exactly what those numbers were, like what the percentage was. It was 1 second that they shaved. I forget what the percentage was and what their annual like gross income was. But I do remember the number that the average developer that same year made $73,000. And the difference that they would have made in that 1 second of shaving 1 second compared to their bottom line would have allowed them to hire 173,000 developers and still make a profit. So they could have hired 100,000 developers, and if those 100,000 developers found a way to shave off 1 second, Walmart would have been in the green. And every developer gets a bonus, right?
That's nice.
And if we're talking about 1 second, all of a sudden the 300 milliseconds is a third of that. And if you can shave off a third of the work in dead time, right? That's just, hey, let's just flip this switch and turn the CDN on or whatever. Walmart already has a CDN for sure. So they probably solved that problem. But the point being that a lot of these problems are solved problems, and you can have big gains. So, depending on the scale of the product, it's a good thing to look into.
Yeah, I do. I like working on performance stuff. At previous companies, I've done performance work and then cut down load times and content load times and time to first byte and stuff like that. And it's a great space to work in performance, if that's kind of like what your bag is. Like I give a talk on performance. It's called Hacking the Human Perception, and it's all about what time to first byte is and time to first paint and different bottlenecks and critical rendering path and solutions to those things and solutions to those bottlenecks and different stuff like that. But let's get into the edge computing stuff. And let's talk a little bit about that, A/B testing. We got some time left. Let's jump into that. Because when I think of like edge computing or edge compute, I'm thinking like standing on the edge of the world, quantum, laser, mechanical.
Yep.
This is the bleeding of the bleeding edge. But that's probably not what it is it?
No, it's definitely all that and more. No, I don't know. It basically, like, edge compute is, again, that concept of like, what is an edge? A CDN is a good example of what an edge is. But an edge is like an edge is a device as close to the user as possible. Like you somehow have a network of multiple devices and figure that out. So does that mean the edge can be my phone? Yeah, technically, if you're talking about like IoT, it could be your light switch if your light switch is like connected to the internet or whatever. So it can mean a lot of things. In the concept of web development, I'd say the edge is kind of this idea of CDNs and safe to stick within the CDN world. And then you have, well, how many computers do you need to make up a CDN? I think some of the some providers, like I think Dino has like 11 computers around the world, and that's like their CDN. And cool, that's great. 11 strategically placed computers can really cut down time. But if we're talking 11 versus, I really need to be careful about comparing to other providers, because I don't want to disparage. I don't talk poorly about other providers, because one, I don't get to see behind the curtain, right? Like I can talk highly about Akamai because I get to see what's going on. But this is the one comparison that I do think is worth making, because it's a matter of scale, right? I think Akamai has, again, 300,000 servers. I think that's across like 1,200 points of presence. So the actual cities where the servers exist. So we're talking about like orders of magnitude of CDNs, right? So again, it depends on what your needs are. But what edge compute provides us is essentially taking those servers where you would normally be, where what we've been talking to up until now has been static assets, and putting essentially functions in there. And these functions can basically live between a user's request and your origin server. And they may be able to replace the origin server. The origin server being the server where your application is deployed to, right? So what they can do is you can think of it sort of like as an HTTP middleware, where a user makes a request to your server, but your like architecture or infrastructure is set up in such a way that the request will always go through the edge node, and the edge node again is going to be probably in the same city as where the user's request is because it's on the CDN. So user's request goes to the edge node. We can ignore how much latency that is because it's so close. Or maybe I shouldn't say that. I need to be careful just because I do, because I represent the company. I don't know how much I can actually say, but user goes to edge node, which is supposed to be as close to the user as possible. And then edge node, if it decides, well, it runs some logic based on the request. And you can do some cool things there. You can say, hey, if this person is using this device, return the request right away or something. Or if they're requesting an asset that doesn't exist, or if they're not logged in, or if they don't have the authentication cookies, just kill the request there immediately. Don't even let that request go all the way through to the server. So you can do some really interesting logic there. But then you say, okay, well, it's an authenticator request. Let's let them go to the server and do whatever the server needs to do as far as like more actual logic. And then the server can respond with a response. The response goes through the edge node. The edge node can run some more dynamic logic on that, and then that goes to the user. So I know that, yeah, we're we spent so much time talking CDNs, we're not getting to the meat of the show. But the meat of the show is like, hopefully that explains sort of what edge compute is. It's basically functions that can do dynamic processing on requests and or responses. And you can even use it you can build routing at the edge and build like an application at the edge. Edge functions are much more limited on resources in terms of how much time they have to respond to the request, or how much time they have to actually run a function in the edge in the logic, and how much memory they have. But aside from that, you can put an application there if you live within the constraints. But where this gets interesting is being able to take a response from a server and be able to modify it, right? So this is where we start overlapping with A/B testing. Because A/B testing, let's say maybe a good A/B test example is you want to serve ads. And you want to say, well, which ad is better? Or you even want to, let's say you have a button, right? And you want to say, I want a button to be red, and I want to test whether it works better if it's green. So you can do that in a number of different places. You can do that with A/B testing by saying on the client, we're going to get the response from the server. The server, that button's going to be red to begin with, or maybe we hide the button to begin with. And then we wait for some JavaScript to load. So JavaScript might talk to an A/B testing service like Split and say, hey, which flag should be on for this user, green button or red button? And then JavaScript loads, figures out that logic and says, oh, this user is supposed to get the red button. Cool, we'll show them the red button. We'll show the other user the green button. And we'll see over enough users which one gets clicked more. You can do that on the client side. You can do that on the server side, right? So instead of putting it on the client, you can say, oh, we don't want to put the extra JavaScript on the client. Let's move that logic to the server. So client makes a request to the origin server builds out the logic of the page, gets to the button, says, oh, hold on, we need to figure out who this user is using cookies or sessions or whatever, and whether they should see the red or the green button. And that again can talk to Split on the back end. And then server builds the rest of the page, puts the button on the page, gives it back to the user. So the interesting thing is, well, why not move that logic as close to the user as possible so we don't have the logic running on, we don't pay the penalty cost, or the user doesn't pay the penalty of running the JavaScript logic on their end and having to wait for the communication to Split, right? We don't put that logic into the server because it takes more compute effort on the server or whatever number of other reasons. What we can do is have the server respond with the HTML of the page that includes the button, whatever the default color of the button is. Maybe the default color of the button is blue. And as the data is actually being streamed from the user or from the server to the user's response, we can actually take some logic and manipulate that HTML at the server level, or at the edge compute level, and say, cool, we found the HTML for the button. We know that this user's cookie says that this user should see the red button. Modify that button, make it red. And we know that this other user with their edge node is receiving another response with the button, and based on their session or even like just randomly checking or whatever, we're going to give them the green button. And that information on, whether on which button they should see. Yeah, I think a cookie is a good spot to store that information. Now,
I was going to say, so if anybody isn't familiar with Split software, we are a feature management and experimentation platform. So we do A/B testing, feature flags, canary release. So we also have SDKs for and it's great that you brought this up, Austin. We have front end or server side, client side SDKs. So, .NET, Java, we have the front end, Angular, React, vanilla JavaScript. We also have mobile SDKs for iOS, Android, and React Native. So you could use those edge functions, right? You could use them in the server side. You could use them in client side. But essentially with this specifically, you're not really using, are you using the SDK on the client or the server, or are you putting an SDK like in the middle?
You're saying for the edge compute?
Yeah.
Yeah. So this is where things get interesting. This would rely on an SDK. Well, we're going to talk about like just a hypothetical edge compute generic system, right? You would probably put that SDK in the edge node. And then the question is, in all of these scenarios, you have to ask the software, the SDK. In this case, we're talking about Split, right? But you have to ask that bit of logic, what flag should be turned on, and how and when, right? And that relies on some sort of stored data. So I think if we're talking about from a client, whether it's a web page or a mobile web page, right? If you're doing that logic on the client, then most likely that's going to talk directly to like Split's service, right? So you, Chris, you're a customer, you have Split, you want to do your buttons red or green, you have an account with Split, you're going to log into Split, you're going to say, hey, I want to create this new feature flag, we're going to call it button color, and it's going to have two options, one is red, one is green, we're going to do a 50-50 split on traffic, right? So the client SDK is going to say, cool, before I actually show this button, I need to make a request to Split with your logged in credentials so that I can see which feature flags you have available. I'm looking for this button color one. I need to figure out what color this needs to be. And it's going to send that response. That data is being stored in Split, right? In Split's database. When we're talking about the server side logic, that request, client makes the request to the server. Server is building out the HTML. HTML needs to figure out, okay, when we're building the button, what colors need to be. I need to talk to Split. And I think Split has some sort of integration so that you don't have to then wait to make another request to Split. I think that Split does integrate with like your own database, so you can keep all of the logic in your stack, right? Which is again a performance consideration, because if user has to go, if the request has to go user to server to Split to server to user, that takes longer than user to server to database back to user, right?
Right.
So that same problem applies at the edge. And the edge is really interesting, especially if we're talking about data, because eventually if you have stored data somewhere, you kind of want a centralized place to write data to, but then you can distribute that data and make reads from anywhere, right? So the architecture that we see most frequently with like distributed databases or distributed data is you have one place to write to. So all the requests to change something go to a single place. And then that single source of truth might be responsible for distributing copies of that information to whatever other stores it needs. Now, that might be another database in multiple regions, where those are like replica databases, and then all of those regions might read from that database, because ultimately, if everyone still has to go back to a single place, you have the same problem that we've been trying to solve from the very beginning of this conversation, right? So what Edge Compute offers is almost every provider, again, has some sort of KV store or key value store. So when you have this feature flag checking at the edge, what you would likely see as the architecture is user makes a request. Request goes probably back to the server, because the server is maybe going to talk to the database or do some logic to build the entire response. The response is going to pipe through the edge node, and then this is where the sort of critical architecture understanding happens, is that the edge node, when it comes to that button that needs to do the actual flagging of turn something on, turn something off, red or green, instead of having to do a request to split or do a request to the server to say, hey, what date, like what button, what color does this need to be? What flags do we have turned on? What you would want is do a request to the KV store of that edge node. So the data is actually right there. I mean, immediate lookup we're talking. And the way that gets set up is a software like Split. When a user like you, Chris, logs into Split and turns on your feature flags and says, hey, instead of red and green, we want red, green, and blue, that data needs to be distributed out. There would be like some sort of logic where Split would then update Akamai's user account, modify how the KV data is stored and what data is stored there, and update the information at the KV store level, so that when the edge node gets this new request and it's trying to figure out what color the button needs to be, it goes to the KV store in the same node or the same location and says, oh, we have 3 colors now, let's do this one. Was that clear?
Yeah, no,
okay.
It all makes sense. If anybody wants to actually like test this out for themselves, I put a link in the chat. If you want a free account, you can go to split.io/signup, and then you can get a free account, free developer account to play around and mess with. Doesn't cost you any money. Speaking about edge functions, and I think I touched on this a little bit, but I just wanted to clarify, since Split, our product does have different SDKs for client side, mobile, and the server side. Can you write those edge functions in all those different types of languages? Like, let's say you're using the .NET SDK. Can you write that edge function in C# and be able to use that SDK together? And same thing with iOS, right? Can you do that in Swift or Objective-C? And in the front end, can you do that in React or Angular, depending on which SDK that you're using for your varying applications?
Yeah, this is going to depend largely across the edge compute provider that you have. Almost all of the main ones offer JavaScript as a programming language. And yeah, so that's the most ubiquitous programming language in the world. So I know that Akamai, we have JavaScript as support. And I think depending, if we're talking about which SDKs you can use, it kind of also depends on, it depends on the edge compute provider and the A/B testing provider. You could roll your own A/B testing logic. We have examples of that in our tech docs on edge compute, on like how you could do that, and store you basically, when a response comes through, you can, let's say, do a coin flip and do a 50-50 on which flag, on red or green for this button example again, and then you would store a cookie on that response and send it to the user, so that the next time that they make the request, you can check the cookie and say, oh, and you can see that this user has already should always get the red button or whatever. So you could do something like that and then figure out how the logic is stored on if they clicked it or not or whatever. Whether you believe in rolling your own A/B testing or feature flagging or not, again, I think you would agree it's sort of the same as the CDN at a certain scale. Sure, roll your own. At a large enough scale, it makes sense to pay someone else to do it. But yeah, I've gone off on a tangent. The answer to your question is it depends on the provider, and it depends on your like A/B testing service, whether the SDK exists.
Cool. No, this has been all great information, brother. I like it. I like the CDN talk. I like how we went on a tangent on CDNs. I like the edge compute. I want to learn more about it. Where can I learn more about this? Let's get it wrapped up for the day. But if our audience and personally myself, I want to learn more about edge computing and how to get that all squared away. Where would I go to figure out that information?
Yeah, that's a good question. I mean, Akamai.com has good resources. Let me pull up a link specifically to our product page on Edge Compute. Where is it? There you go, Edge Workers.
I also just put a link to Akamai.com in the chat, wherever the chat's at. I think it's over here.
Yeah, I don't know. I don't know if I can post directly to. Oh, I can. Okay, or I can see the live stream. Okay, I didn't see that till just now. Well, I just posted it in our chat, and you can repost it or something.
Got it. Here we go.
Let me post another one to the actual documentation for Edge Workers, so you can see a little bit more about the actual what's available, what's built in. Oh, there's something worth mentioning about Edge Compute as well. Is we sort of talked about the challenge with databases, and that you will always have like one sort of like the database is often the biggest challenge with Edge Compute. And let's say you wanted to build an application that runs entirely on the edge. If you need to work with a database, you probably still have like that single source of truth to work with. And then you maybe want to work with like replicate databases. Some of the challenges with Edge Compute is the biggest providers for Edge Compute, none of them support TCP as a protocol, which is, for example, the protocol you would need to use to connect directly to a database. So all of the Edge Compute providers offer HTTP, so you can make like HTTP requests. But if you wanted to connect to a database, you would have to build like a proxy to talk to that database anyway, because TCP is not supported. So there's a number of issues. Also, like I mentioned before, Edge Compute providers have limitations as far as which programming languages they support, which APIs they support as part of those programming languages, how much resources they provide in terms of the amount of time a function can run or the amount of memory it can use. Edge kind of lives under the same sort of umbrella as serverless. So all of these requests are ephemeral, meaning you can't store a file there and expect that file to still be there. You can't store memory. You can't store data in memory and expect that data in memory to still be there on future requests. But the other thing, what was the other thing worth mentioning? Oh yeah, the other thing worth mentioning is the limitation on the APIs that are available. So if you've done server-side JavaScript, you've probably worked with Node. The main Edge Compute providers do not run Node. So you don't have access to the same API to talk to the hardware or whatever. You're more likely working within a limited, a much smaller bespoke runtime. Most of them are built on top of V8. So it's like a V8 isolate. But, if you want to do something like, I don't know, what's one of the things that you might need to do? It's just weird. Like JavaScript is weird because you have the actual ECMAScript language, the actual programming language, and then you have things that are specific to a runtime. So you have APIs that are available in the browser, you have different APIs available in Node, you have different APIs available in Bun, you have different APIs available at the edge, right? So it's worth at least stating that and understanding that some things that you're used to doing in the browser or in Node land are not going to work. So it's going to be different across whichever provider. And there's some interesting work being done as far as interoperability and like community groups that are trying to consolidate everything to have the same APIs across. But we're just like really early on that. So let me see. I sent you a link to Akamai EdgeWorkers, the sort of marketing site. I sent you a link to the documentation site. There's one more link that I wanted to share. Let me see. 1 second. Okay. Yeah. So this is a link here that I have. If anyone's watching is interested. Last year, Akamai acquired Linode. So we're currently transitioning into Akamai being not just a CDN provider, but a full service, full spectrum cloud computing provider. So I have a little bit.ly link here that can get you $100 in credit if you are not currently or haven't been a Linode user and you want to try it out. So it's got all sorts of compute services, like traditional compute, object storage, databases, stuff like that. $100 if that's helpful to anyone.
Awesome. Sweet. Well, Austin, appreciate all the time. I know we had to move this around a couple times, scheduling conflicts and whatnot, but I appreciate you doing this on a Friday. It's a Friday, TGIF.
Friday, woo!
It's Friday. It's been pouring here in Michigan. Pouring, and at least in my hood, pouring rain. I think it's starting to stop. Trying to go paintball later tonight, so we'll see what happens. But like I said, I appreciate you coming on, hanging out, doing the damn thing. Let's see. Twitter.com/ Hey Austin Gill. Find you on Twitter, right?
Yeah. Twitter is a good. I mean, until it burns down, we'll see.
Until it burns down.
I'm on Mastodon too, but it's we'll see. But yeah, currently Twitter is a pretty decent place to find me. And yeah, appreciate you making the space for me to come on. It's been a pleasure, and we talked about a lot of cool stuff that I think is fun.
We'll have to do it again. Next time we're going to write some code. You're going to walk me through setting up edge functions with one of our SDKs and watch me fumble through it. It's going to be
I think I like, I'm a man of many different interests, and I think edge compute is cool. I like to talk about it, but I like to talk about other stuff too. So
yeah,
it'd be fun to we'll figure it out. If anyone that's watching has other interests, let us know.
Yeah, let us know. Let me know on my Twitter at Sultan Burnham. Let Austin know. If you want, hit up the Split Software Twitter account too. It's twitter.com/Split Software. Let's see, who can we raid? Adam.dev, AWS. Let's go to Adam.dev and let's raid Adam.dev.
Mm-hmm.
Adam.dev doesn't know who I am, or he might know who Split is, but he doesn't know who I am. So we're just going to raid him anyways and go from there. I appreciate it. Thank you again for joining me, brother. We'll have to do this again.
Yeah, sounds good.
Ready to raid in 8 seconds. 7.
Here we go. All right.
6, 5, 4, 3. On that note.
Woo! Raid's on.
Peace.